Alright, let's say you've just completed a problem involving an inequality. Suppose that you've just finished this problem. The product of 2 and 3 less than a number does not exceed half the number. Solve the inequality and give the solution set in interval notation. Now there are going to be a lot of steps in solving this problem, and we could make a mistake in any of them. So after we've finished solving this problem, we will go through and see how we check whether we're right or not. Our first step in solving this problem is just to write down an inequality. So our first step in writing down the inequality is to find the verb in this sentence. In this sentence, the verb is does. That begins the verb phrase, does not exceed. Let's see. Exceeds means greater than, so does not exceed is a less than or equal to. What then are our two expressions? Our first expression is a product. We'll have multiplication in our first expression. And then I look forward and I find the next and. This product goes with this and. So before the and we have 2. So 2 will be the first thing in our product. And 3 less than a number. I know what that means. That means x minus 3. Notice, this just says less than, not is less than. That's talking about subtraction, not about an inequality. Okay, and now I'm to the verb, so I've finished with my first expression. Second expression, half the number. Half the number means 1/2 x. Okay, so this is my inequality. I'm going to rewrite it in a slightly neater way. These parentheses aren't doing anything for me. I'm going to have 2x minus 3 is less than or equal to 1/2 x. Okay, now I'm ready to solve this. My first move is to get rid of these parentheses. Remembering that minus means plus the opposite, I'm going to distribute the 2, and that'll give me 2x plus negative 2 times 3 is 6 is less than or equal to 1/2 x. Okay. Now I need to get all of the x's together on one side, all of the numbers together on the other. I see that I only have numbers on the left-hand side, so I'm going to do this by adding negative 2x to both sides. On the left, that just leaves negative 6. On the right, maybe I can work this arithmetic out in my head otherwise. Using the calculator, I can say 1/2 plus negative 2. And I get, I feel like a fraction. Negative 3/2 x. Okay. Now I need to get rid of that negative 3/2. In order to do that, I'm going to multiply both sides by the reciprocal, negative 2/3. And when I multiply both sides of an inequality by a negative number, I must reverse the direction of the inequality. On the right, negative 2/3 and negative 3/2 will cancel, and I just get x. On the left, again, you can use your calculator for this if you'd like, but I get 4. So now my inequality is solved. Looking back here, I see that I'm told to give the solution set in interval notation. So I want to give this as an interval. I find that it's easier, more comfortable to write down intervals when I've written the x on the left. I think that's probably more a matter of habit than anything. But it keeps me focused on the x itself. So let's see. To write down an interval, first of all, I want to say what is the smallest number. The smallest number here, well, there isn't a smallest number that's less than 4. So there isn't a smallest number, so my interval starts at negative infinity. What's the largest number that's less than or equal to 4? Well, 4 itself, and 4 is included, so it gets a square bracket. My answer, my final answer, is negative infinity to 4, where 4 gets a square bracket. Okay. There was so much going on here. How could I possibly check this? First thing we should do is check some numbers in our inequality. Our inequality was 2x minus 3 is less than or equal to 1/2 x. And we claimed that our solution set was negative infinity up to 4. We're going to check two numbers. We're going to check x equals 4, that's the end point. And when we do that, we expect the two sides of our inequality to come out equal. If not, we have the wrong number. And then we're going to choose a number inside the interval. And we should choose a number that makes the arithmetic easy. If it's available, I'm going to choose 0. I'm going to choose, say, x equals 0, since 0 is less than 4, and 0 is in negative infinity up to 4. I expect 2 times x minus 3 now to be less than 1/2 x. If not, less than or equal to is the wrong direction. Okay, so checking x equals 4, 2 times 4 minus 3 equals 2 times 1 equals 2. 1/2 4 equals 2. Those are the same. X equals 0. 2 times 0 minus 3 equals 2 times negative 3 equals negative 6. 1/2 of 0 equals 0. Negative 6 is less than 0? Yes, that's true. Okay, so that tells me that the interval we gave really is the correct solution set to the inequality that we wrote down. The other thing we need to do is look at the story. And in particular, look back at the verb we found, does not exceed. Using the numbers that we found when we plugged in, we need to put the verb does not exceed between them and see if that makes sense. Noting that we plugged into the first expression first, The second expression second. 2 does not exceed 2. Yes, that's true. First expression first. Second expression second. -6 does not exceed 0. Yes, that's true. So what we just checked now was that less than or equal was the right inequality for our verb.